Binary compounds are compounds with only two elements, and we're going to look at how to name binary compounds. First thing I have here are the non-metal stems. You really don't have to memorize these. These are the first part of the element name, but they're called non-metal stems, and I will be referring back to non-metal stems in the naming of these binary compounds. There's three types of binary compounds. The first are binary acids, which have a hydrogen and a non-metal. When you name binary acids, you name by using the prefix hydro, then the non-metal stem, go back to that list, and then the suffix is ic acid. So let me give you a couple examples. HF is a binary acid. It's got hydrogen and a non-metal. So the way to name it would be hydro, non-metal stem is F, so that's fluor, and the suffix is ic acid. So HF is hydrofluoric acid. Now if you work backwards, let's say I give you the name hydrosulfuric acid, and I say what's the formula? It's a binary acid, it's got hydrogen, and in this case sulfur. But I do have to balance charges. Hydrogen, when it's with a nonmetal, is positive 1. Sulfur is in group 6A, so that means it has a charge of negative 2. Cross charges, hydrosulfuric acid is H2S. Second type of binary compounds are binary salts. These have a metal and a nonmetal. We're going to name by using the metal name, then the nonmetal stem, and then the suffix is -ide. So for example, CaO, that's a binary salt. It's got a metal, calcium, and a nonmetal, oxygen. Metal name is calcium. The nonmetal stem, it's oxygen, so it's ox. And then the suffix, IDE. So CaO is calcium oxide. Let me go through a couple more examples of binary salts. If I give you the name, let's say I give you titanium phosphide and ask for the formula, it's a binary salt. It's got a metal, titanium, and a nonmetal, phosphorus. But just like before with the acids, we have to balance charges. Titanium is in the B groups, and most B groups have a positive 2 charge. So this has a positive 2. Phosphorus is in group 5A, negative 3. Cross charges, titanium phosphide is Ti3, P2. Let's do one more. Gold carbide. Gold is Au. Carbide is just carbon. Get the charges. Gold is in group 1B, which means it has a positive 1 charge. It's with copper, silver, gold have a +1. And then carbon is a -4. So gold carbide is Au4C. So those are binary salts. Now with these binary salts, it is possible to have multiple valences because some B group metals have more than one possible oxidation state, which is indicated by a Roman numeral. And these are the 6, and we've mentioned them before, but here are the 6: iron, copper, mercury, tin, chromium, lead. So if it's one of these 6, you will see the charge indicated in Roman numerals. So let me go through a couple examples with these multiple valences here. For example, if I have lead, I need to indicate the charge. It's possible for lead to have a +2 charge. So let's say my compound is lead 2 nitride. That 2 means that lead is a positive 2. It can also be a positive 4, but in this case it's +2. If I put it with nitrogen, which is in group 5A, which has a -3, my compound is going to be Pb3 and 2. So that's lead 2 nitride. There's also a compound, since lead has more than one charge, there's also a lead 4 nitride, which simply changes the charge on lead. Instead of a +2, it's a +4. Now nitrogen's still a -3, but when you cross charges, you will see you get two totally different compounds. So those Roman numerals indicate the charge for the metal. Let's say you have this compound, CuO. It is a binary salt, which means it's going to be just the metal name copper and then oxide. But since copper is one of those that have multiple valences, I need to indicate the charge. Oxygen is a -2 almost all the time. So if oxygen is a -2, in this case, copper has to be a +2 to cancel out. So I actually need to indicate, since copper is one of those metals that have multiple oxidations, I need to indicate the charge on copper. So copper 2 oxide. Okay, so that's binary salts. The third type of binary compound, we're going to use prefixes. So here are the prefixes 1 through 10, and these are going to indicate how many atoms we have. We only use prefixes with binary nonmetal compounds. So binary nonmetal compounds, combination of two nonmetals. We're going to name them just like binary salts, so the suffix is going to be "-ide". The only exception is I have to use prefixes to denote the number of atoms. So let me go through a couple of examples. Cl4. That's two nonmetals put together. Carbon. Since there's 4 chlorine, I need to indicate that with the prefix. So 4 would be tetra, and then chloride. So you see the suffix is just like binary salts, the IDE. The only difference is we're using this prefix. Now, I could have said monocarbon. I could have put the mono there, but you don't have to put mono if it's the first element. So I could have said monocarbon tetrachloride, but more often than not, you're just going to see carbon tetrachloride. However, if my compound's like CO, you have to use mono for the second one. So I would have to include carbon monoxide. I would have to use that that prefix for the second element. So carbon monoxide for that one. Let me go through a couple more on these binary nonmetal compounds. Let's say we have sulfur. I'm going to give you the name. Sulfur hexa iodide. That'd be S. Hexa means 6, I6. The good thing about these binary nonmetals really is you don't have to worry about charges. I don't have to do the plus and minus and cross the charges because it's telling me how many there are. There's 6 I's. There's 1 sulfur. So we do not have to balance charges with these binary nonmetals. Do one more. Diphosphorus decabromide. Diphosphorus means there are 2 P's. Decabromide, Br, deca means 10, so this is my compound. I would not reduce in this case because it's telling me there are 2 and 10. And so binary nonmetals, we don't have to worry about charges, and we also don't really reduce if we can. And this is just a special type of binary compound. So 3 types of compounds for binary: binary acids, binary salts, binary nonmetal compounds.